This is the summary created from the video. Lecture 11 Java Static Scope Rule. The scope rule in Java governs the accessibility of identifiers within a program, making it a crucial concept present in all programming languages. Java follows the static scope rule, which determines the visibility of variables and methods at compile time, as demonstrated by examples like the box and circle classes. Variables declared within a method have scope limited to that method or a specific code block. While attempting to access them outside their defined scope triggers a compilation error. Instance variables have separate copies for each object, while class or static variables have one global copy shared among all objects of that class, as illustrated by the circleCount variable in the circle class example. Methods can also be declared as static, making them class methods accessible without creating an object, while instance methods require an object to be called, allowing for method overloading with the same name but different parameters. Java supports nested classes, where a class is defined within another class, although they are rarely used and can introduce errors if not implemented carefully, as demonstrated by the point class nested within the circle class. Recursion is an important concept in programming that allows a function to call itself with different input parameters, enabling the solution of complex problems through a clear understanding of the problem and a well-defined base case. The concept of recursion is demonstrated through examples such as calculating the factorial of a number, where the factorial function calls itself with decreasing values until reaching the base case of 0 or 1. Another recursive example is the calculation of the Fibonacci series, where each term is the sum of the previous two terms, with the recursive function calling itself with n1 and 2 as arguments until reaching the base cases of 0 and 1. The recursive calculation of the greatest common divisor GCD of two integers is also presented, where the recursive GCD method calls itself with different input values at each step until reaching the base case. A brief recursive example is introduced, prompting the viewer to guess the output, suggesting that understanding recursion aids in explaining the program's behavior. The lecture concludes by emphasizing the importance of the static scope rule in Java and mentioning that the next lecture will cover information hiding concepts and how large Java programs are structured. Key takeaways include the static scope rule determining identifier visibility at compile time, the difference between instance and class variables, static methods operating at the class level, nested classes providing localized code, recursion enabling self-referencing methods for complex logic, and recursive examples like factorial, Fibonacci, and GCD calculations. Please stay tuned for more summary videos.